So here we are behind the Plant Sciences building on campus, looking at this little stream, and we're going to be talking about the creation of sinuosity and sediment transport and deposition. So essentially what this stream is doing is, originally it started as something that would be straighter, and it found a weak point along one of its banks and started to incise that. So you start to create a little bend, and that changes the velocity of the water and the flow. And so what you start to develop is a cut bank. So you can see that we're looking at a curve, and over here it's cutting, and over here it's taking sediment that was eroded and it's depositing it, making a little point bar. And as these curves continue to grow, it's going to cut this bend so it's tighter and tighter angle, and eventually it's going to punch through over here and create a little oxbow lake. So the way that we measure sinuosity is the length of the stream channel, which is measured, literally just following the path of the stream, and comparing that to the straight line distance between 2 points. So a straight line distance would cut from here over the point bar to back to the stream. So for sediment transport, essentially there's 3 ways that this can happen. It can travel in suspension, you can have dissolved particles, or you can have bed transport, which is through saltation and rolling. So one of these little grains would bounce along the bottom or roll along the bottom. And you get sediment transport when critical shear stress, which is the force per unit area of the river on the bed, exceeds your boundary shear stress, which is your resistance force.